This is the origin story of DNA ligase joining Okazaki fragments during DNA replication. DNA ligase fills the open spaces between the fragments to make the discontinuous strand continuous. Let's meet the stars of this week's episode. This week on Enzyme Tales,
the Okazakis visit Dr. Larry Ligase for couples counseling. First, let's meet the Dr. Larry Ligase. Hi, I'm Dr. Larry Ligase, and I'm an enzyme aiding in the ligation of the Okazaki fragments during DNA synthesis. I am an enzyme with a magnesium 2+ as a cofactor. I have 3 lysine residues. 2 of the residues are responsible for stabilizing the intermediates of the reaction, and the 3rd lysine is responsible for the covalent catalysis of the Okazaki fragments. This form of catalysis changes the reaction pathway by encouraging the formation and breaking of certain bonds. Here's some background information on myself if you or someone you know needs some relationship advice. My credentials include a PhD in counseling, which I completed at the University of Enzymatic Activity. I specialize in lagging strand location therapy. My previous work experience includes McDonald's, which is where I found my knack for counseling because people in the drive-thru would always trauma dump on me. This tale also includes my dog Amy and Daryl and Daphne Okazaki. Hi, I'm Dr. Larry Ligase, and let me tell you a story about how I connected 2 people with a very broken relationship. Their names are Daphne and Daryl Okazaki. They were a lovely couple, but they were very separated by their vices and their peers. So tell me, Mr. and Mrs. Okazaki, what brings you 2 in today?
We feel so separated, and I feel no connection to him. I try to reach out, but I always feel like something's blocking me.
Okazaki fragments are kept separate by single-stranded binding proteins, which prevent the DNA template strand from folding back on itself and creating intramolecular bonds.
This is a common occurrence that I see in every half of DNA's relationship, but don't you worry, this is my specialty. Let's try an exercise that regularly fails me with my other clients. Today I have brought in my therapy dog, Amy, to aid in connecting your relationship. She is a pro at forming a bond between fragmented connections. Oh no, that darn dog.
The dog amine represents the amino group of lysine 34 acting as a nucleophile and attacking the alpha phosphate of ATP. The chew toy represents AMP, while the basket is the diphosphates that are removed from ATP. This represents the nucleophilic attack of the first DNA fragments, creating the DNA-AMP complex. This represents the nucleophilic attack that the second DNA fragment does to the DNA-AMP complex, removing AMP and resulting in ligated Okazaki fragments.
Wow, in a matter of seconds I feel so much more connected to Daphne. Our relationship has never felt stronger.
That's fantastic. I am so glad to hear. Shall we discuss the mechanistic take on the exercise that we went through today?
I would love that.
I have a great animation that explains what happened today.
In the active site, lysine 34 acts as a nucleophile on the alpha phosphate of the adenosine triphosphate. This reaction is a substitution reaction that removes the diphosphate and forms a covalently bound ligase adenosine monophosphate intermediate. The magnesium 2+ stabilizes the double-bonded oxygens in the intermediate electrostatically. Lysine 238 and lysine 240 stabilize the intermediate through hydrogen bonding and electrostatic interactions. Additionally, lysine 238 positions the beta phosphate in a favorable position so substitution can occur with the lysine 34. The oxygen on the first DNA fragment then acts as a nucleophile and attacks the phosphate lysine 34 complex. This is also a substitution reaction which removes the lysine 34 and forms a DNA-AMP complex. The magnesium 2+ electrostatically stabilizes the intermediate, and lysine 238 and lysine 240 also stabilize the intermediate through hydrogen bonding and electrostatic interactions. This is the DNA-AMP complex after lysine 34 has been eliminated. The phosphate on the AMP deprotonates the hydroxyl group on the other DNA fragment. The fragment can then act as a nucleophile and attack the DNA phosphate of the DNA AMP complex, again in a substitution reaction. This removes the AMP from the active site. Magnesium 2+, lysine 238, and lysine 240 are still stabilizing the intermediates through electrostatic interactions and hydrogen bonds. After the bond is formed between the second DNA fragment and the DNA AMP complex, and the AMP is removed from the complex, the now joined Okazaki fragments can leave the active site and the reaction is complete.
You really are a pro, Dr. Larry. We sure will refer you to all our friends.
Whoa, looks like Larry's gonna be booked solid for the next month. Tune in next week for our episode on the life story of Sally, the single-stranded binding protein.